Today, we're going to be detectives. We're investigating a really strange connection, the one between some common, life-saving drugs and the mysterious rashes they can sometimes leave behind. So, let's dive in. You know that feeling? You start a new medication, everything seems fine, and then a few days later, there it is, a strange rash. It's a surprisingly common thing, but it makes you wonder, right? Why does it happen with these drugs and not others? Well, it turns out it's not random at all. In fact, it's a sign of a fascinating, really complex biological story that's playing out right on your skin. So today, we're going to put on our detective hats and uncover the clues behind these rashes. Okay, first things first, let's identify the main subjects of our investigation, a class of drugs that work on the autonomic nervous system, or the ANS for short. So, what are these ANS drugs? Well, they're medications that help manage all the stuff your body does without you even thinking about it. Things like regulating your blood pressure or your heart rate. We're talking about things like beta blockers for heart conditions or certain antipsychotics. And while antibiotics usually get all the attention for causing rashes, these ANS drugs are actually a major player, which makes them a perfect case for us to crack. All right, let's bring in our first culprit. This one is all about an immediate, direct chemical reaction. It's the fast and furious one. We're talking about urticaria, but you probably know them better as hives. Those sudden, red, super itchy welts that can pop up out of nowhere. They appear fast, and the key chemical pulling the strings is something called histamine. So here's how it goes down. Think of these little things called mast cells in your skin as, well, as overeager security guards. The drug molecule comes along and basically just pokes these guards. And in response, they totally freak out and just open the floodgates, releasing this massive wave of histamine. This histamine then makes your blood vessels all leaky, fluid pools in the skin, and bam, you've got hives. Okay, culprit number one is down. But what happens when there's an outside accomplice involved? For our second culprit, we need to talk about the sun. This is a little thing called photosensitivity. Now, it's not an allergy to the sun itself. It's a situation where a drug makes your skin dramatically, and I mean dramatically, more sensitive to the UV radiation from sunlight. And this chart here, it tells the whole story. The drug by itself, barely any reaction. The sun by itself, well, that's just your normal risk of getting a sunburn. But you combine the two, the reaction skyrockets. We're talking a really bad sunburn, blistering, or a rash just in the areas the sun touched. It's a classic case of two things being so much worse together. And now for our final and definitely our most complex culprit. This one is a classic case of mistaken identity, and it's orchestrated by your very own immune system. This is where things get a little sneaky. This is what's known as a delayed hypersensitivity reaction, and that word delayed is absolutely key here. Unlike hives that pop up right away, this reaction can take 1, maybe even 2 weeks to finally show up. And that delay is what makes it so hard for people to connect the rash back to the drug they started taking. So here's the story. A tiny molecule from the drug latches onto one of your own normal skin proteins. This creates a brand new, totally unfamiliar structure. Your immune system's T cells, which are acting like really confused security guards, see this new complex and have no idea what it is. So they flag it as a dangerous invader and launch a full-scale inflammatory attack. The result? That widespread red rash that shows up a week or two later. So let's put all our suspects in a lineup. We've got the histamine reaction. It's fast, we're talking minutes to hours, and looks like itchy hives. Then there's photosensitivity. It only happens with sunlight and looks like a bad sunburn. And finally, the immune mix-up. It's slow, taking weeks to show up, and usually looks like a widespread red rash. 3 totally different culprits, each with its own MO. Okay, so we've identified the how, but that leaves one really big question. Why? Why are these ANS drugs in particular so likely to cause these kinds of reactions in the first place? Well, a huge piece of the puzzle is the drug's actual physical shape. Think of it like a key trying to fit into a lock. Simpler, smaller molecules are kind of like smooth keys. They can often just sneak right past the immune system's defenses. But a lot of these ANS drugs have really complex, bulky, ring-like shapes. They're more like a key with a bunch of jagged edges. And those larger, more complex shapes are just way more likely to get snagged, bind to skin proteins, and get flagged as an intruder. It makes them more immunogenic. But the drug structure isn't the whole story. It's more like a perfect storm of factors. For one, the skin itself is just packed with those vigilant T cells we talked about, making it a natural hotspot for these immune reactions. In some rare cases, you can get a really severe reaction called DRESS syndrome. And it gets even more specific. Different drugs have their own signatures. Beta blockers, for example, are known to cause these very unique lichen-like rashes. And this quote right here, it just nails it. The skin isn't just a passive barrier. It's an active, alert immune organ. It's totally primed and ready to react. That high concentration of memory T cells makes it the perfect stage for these delayed drug reactions to play out. So the bottom line is this. The next time you see or hear about a rash from a medication, you'll know it's not just some random, inconvenient side effect. It's a clue. It's a sign of this intricate dance happening between drug chemistry, sunlight, and the incredible, mind-boggling complexity of our own immune system. Which kind of leaves us with one last thing to think about. If our bodies can mount these incredibly specific and complex responses to drugs that are actually designed to help us, well, it just makes you wonder, doesn't it? What other invisible battles, what other incredible balancing acts are happening inside us every single moment of every single day?